Hello, my name is Mark Fennell, and today I'm going to talk to you about fracking for natural gas. What I'm going to talk to you can be found in this book, Natural Gas Technologies Explained Simply. And I will provide some highlights of fracking, but much more of the details will be found in this book than what I'll be presenting in the video. Also note that because I'm going to present a lot of details, I cannot do these details from memory. I will be referring to actual pages in this book as I go through the video. Fracking is very important in natural gas. It has environmental consequences. And there are lots of people throughout the world who are concerned about the environmental impact of fracking in natural gas wells in their area, the effect that it has on the nearby aquifers and water tables. It is because of this that I have done extensive research to provide some extensive data in this book, and I'm going to highlight some of the basics, the most important facts in this video. So first of all, what is fracking? Let's begin with where most natural gas is found. Most natural gas is found in wells. These wells can be water wells, oil wells, any place where you find coal or diesel or oil, any number of things underground will also have the natural gas, the methane. Now with the wells, usually what happens is there's a pump, and it'll pump up all the, for example, all the kerosene and the oil and the natural gas, and it'll be taken out. But then there's natural gas stored behind rocks in the well. There are these porous rocks that the methane has found their way into. And in some cases, they're not just into the porous rocks, but they're behind the porous rocks and into some crevices within. So there's a lot of natural gas there, but what we need to do is basically chop away at that rock, get it out, the natural gas will come through. This, of course, is underground, not above ground. So we need a way to go down into the well, attack those rocks, and then bring out the natural gas. That is what fracking does. Fracking is any process, by any means, and there are several, which breaks apart the rock. Now, several methods are commonly used, one of which is water. A heavy dose of water spray. You're very familiar with this. If you use a high-powered water spray, it'll make chip off paint. That's exactly what we're doing. It chips off the rock. There's also sandblasting. They literally send sand at a high pressure down in there, and it'll break apart the rock. They also use acids. Acids will react with the rock, breaking it apart, and then the natural gas will come through. Typically, all these methods are used at the same time. The basic process, what happens for fracking? They first decide that they need it. They will put their pipes down. They'll put a sealant on top. Ideally, with that sealant on top, nothing will come through. They'll break apart everything they need. They'll send in chemicals to break apart what they need. Then they will put in a new tube which will suck out. They'll suck out all the new rocks they've broken up, all the wastewater, all that sand and gravel, and take that out. And then ideally what's left is the hole, and you can pump out the natural gas. That is the basic process of fracking. Now what becomes the environmental issues are the following. First of all, there's a lot of quantities of water used. We're talking 4 million gallons of water sent in the fracking process. Then the wastewater comes back out. There's at least 4 million gallons of water, if not more, coming back out. Then there's the acid that's sent in. There's millions of gallons of acid that's sent in. Some of it's unused, some of it's left over, comes back out again. So you have all this sand and water and acid being sent in. That can interact anywhere in the rocks, including any local aquifers. As it's sucked back up, once again, that's a second route, comes back down, can go through the aquifers, suck back up, can also go through the aquifers. And even if none of it actually goes through, even if the pipe contains all of it, we still have all this wastewater to contend with. And what do we do with it? Just pour it back into the reservoirs? That's not going to be good for the fish, not going to be good for the wildlife. So we got to consider all that. I'm going to now get into some numbers, and I have to refer to my book for this. How much do we have of various things? The amount of water that is used is between 2 million and 4 million gallons per well. Now, where does that water come from? It's got to come from a local river, some other source. And if it's being used from a local river, a local lake, it's used, it's gone. It's not reusable. So it's just taken out. Nobody can use it. Chemicals. A typical mixture has about 85% water and 15% acid. That is still around 400,000 gallons to 600,000 gallons of acid per well. So let's say 500,000 gallons of acid per well for one fracking operation. Then there are other chemicals that are sent in as well. Most of those are what they call propping chemicals, which means they prop open the holes in the, when you make a hole inside the rock, this keeps the hole open. There's also lubricants that are inside the pipe that keeps it from friction so the liquid can come up and down. Those chemical additives vary from well to well, but it ranges from 10,000 gallons to 80,000 gallons per well. Okay, so we have 4 million gallons of water sent in, 500,000 gallons of acid, and up to 80,000 gallons of other chemicals. It's all being sent in. Now, those things are coming out again as wastewater. They have to be contained. They cannot be used again. But what you can do is you can do through a filtering operation. One step of filtering operation, you can use it for the local grass. Another step of filtering operations, you can use it for local wildlife. But again, you really have to think about this. There are two best uses of wastewater. The first one is for subsequent fracking operations. Instead of taking 4 million gallons of water out of every single reservoir, you keep that 4 million gallons and you use it in the next fracking operation and the next fracking operation. It already has some acid in it, already has some chemicals in it, might as well just reuse it. The second thing it's good for is for putting out forest fires. When we have a large forest fire, we need as much water as we can get, and we really don't care about the toxicity because most of the time it has to be cleaned up anyways. So that's a good source where helicopters and other people can come in, take the wastewater, dump it on a forest fire. I would not recommend this for using for municipal water or for drinking in any way. So. Okay, so a summary of fracking. I have a lot more details of fracking in this book. But the basics is there's always some natural gas stuck behind rocks in the well. Fracking is any method which breaks apart those rocks so the natural gas can come through. It's usually a mixture of high-pressure water, high-pressure sand, and acid, which breaks apart the rocks. There's a lot of water sent in, a lot of acid sent in. Therefore, there's a lot of wastewater which needs to be collected and set aside. Aquifers can be damaged because the acids can come through the pipe system on either side and go through the cracks. It's best, and a lot of good companies do this, they put a seal on top so that nothing comes up, and they put a seal on the sides so that next thing nothing goes through where they don't want it to. But you have to be careful and look at that. Now, if you're a concerned citizen, you also need to know the following. Not all fracking is dangerous. There are good, environmentally sensitive companies out there who do fracking and who do not damage the aquifers. Also know that every company operates differently. Every well requires a different combination of chemicals. There is no one-size-fits-all, one combination. If fracking is going on in your neighborhood, you have to look at the specifics of what they're putting into the well and how they're protecting the aquifers. And if you need any more information, please check out my book, Natural Gas Technologies Explained Simply. Thank you.